Flipped Classroom video for Maths AS Unit 1, Polynomial Introduction and Basic Operations. What is a polynomial? Well, a polynomial is a function which is a sum of multiples of positive integer powers of x and, optionally, a number. The highest power of x is the degree of the polynomial. So, the easiest way of making sense of all that stuff is to have a look at some examples. So x plus 4 is a polynomial. We have x to the power of 1, which we write as x, so that's an integer power of x, and we have optionally, in this case we do have plus a number, so x plus 4. That's degree 1 because the highest power of x is x to the 1, which gives us degree 1. X squared is a polynomial. That's degree 2. And of course we call that a quadratic. Now, jumping into a much more complicated job, we have 3x cubed minus 2/5 of x squared plus 5x minus 3. So, all the powers are whole numbers, or positive integers. We've got x to the 3, x to the 2, x to the 1, and effectively x to the 0, but that's just the number 3. The multiples don't have to be integers, so we have 3 times x cubed, but we have a fraction, minus 2/5 times x squared plus 5x minus 3. So that's a polynomial. That has degree 3, that's the highest power, x cubed, and that makes it a cubic. And we can go on. Here's another random example, x to the power of 6 minus 8x to the power of 5 plus 7, and so on. And what would the degree of that be? Well, the highest power is x to the power of 6, so the degree is 6. It helps to contrast that with what aren't polynomials. So we'll have a look, just a couple of examples of that. Perhaps your teacher will show you some more. But the square root of x plus 4, that is not a polynomial. That is x plus 4 to the power of a half, in fact, and a half is not an integer power, and the powers have to be for the separate x's anyway. X to the power of 6 minus 8x to the 5 plus 7 over x, well, 1 over x is the same as x to the power of minus 1, and the definition of the polynomial is that you have to have positive integer powers. Now that's a negative integer power, so not allowed. So neither of those are polynomials. And you've seen quadratics, you've probably seen cubics, and a general polynomial might look like that. They have a sort of particular look to them. They've got maximums, minimums, and often, well, generally I suppose, cross the axis, not always. And those maximums and minimums are called turning points, as you probably know, and where they cross the x-axis are called roots. Okay, so we can do things with polynomials. We can add them together. So if we look at these two polynomials here, if we want to add them together, we could do it by inspection, just working our way along each of them, but I'll lay it out for you to make it easier to see. So I've written f of x and g of x, and I've written them so that the powers are lined up in a similar way to the way that we line up the figures in a number to make sure that we're adding the right powers of 10. In this case we're making sure we're adding the right powers of x together. And so when we add them, we have x to the power of 6 plus x to the power of 6 is 2x to the power of 6. We have minus 8x to the 5 plus x to the 5, which gives us minus 7x to the 5. We have nothing plus 3x to the 4, so that's just 3x to the 4. We have nothing plus minus 8x cubed, which is minus 8x cubed. The 7x squared, which is part of f of x, again there's nothing to add to that one, so that's 7x squared. But then we have an x in both of them, so they add up to 2x. And finally we have minus 6 add minus 1, which is minus 7. Subtraction works in a similar way. We line them up and then we subtract. So When we subtract g of x from f of x, we have x to the power of 6 take away x to the power of 6, which is nothing, so I've just written nothing there. We have minus 8x to the 5 take away x to the 5, which is minus 9x to the 5. Nothing take away 3x to the 4 is minus 3x to the 4. Nothing take away minus 8x cubed is plus 8x cubed. Then we have 7x squared take away nothing is 7x squared. X take away x is nothing, so I haven't written it. And then minus 6 take away minus 1 is the same as minus 6 plus 1, which is minus 5. And what we might notice here is, for the degree, when you add polynomials, the new degree, or the degree of the added polynomial, is going to be the maximum of the degrees of each of them. Now in this example, they're both x to the power of 6, but if we had one, say if we'd had an x to the power of 7 in one of them, an x to the power of 6 in the other, this sum would still have an x to the power of 7. So it's whichever is the highest degree of the ones you're adding. When you're subtracting, that isn't necessarily the case, because if they match, as they do here, we end up with a degree for the subtracted polynomial which is different from either of the original ones, and that's because the x to the power of 6 matches up in this case. So there's no obvious general rule there. So we've looked at adding and subtracting. We can also multiply polynomials, and you've already done polynomial multiplication because you've multiplied linear functions. So 2x plus 3, if you mapped that, it will give you a line, as would 5x minus 7, and you've multiplied them together. So if we have f of x times g of x, in this case 2x plus 3 times 5x minus 7, and you would have your familiar FOIL, FOIL, or there's other ways that you may have been taught this, but that gives you a way of working through. So if we do the first term from each bracket, multiply them, 2x times 5x is 10x squared. The outside, we've got 2x times minus 7, which is minus 14x. The inside is 3 times 5x, which is 15x. And then the last from each bracket is 3 times minus 7, which is minus 21. And we can then combine the minus 14x with the 15x to give us plus x, and we have 10x squared plus x minus 21. And in this case, we can see for this example that the degree of f of x is 1, that's the highest power of x, and the same for g of x, and 1 plus 1 is 2, which is the degree of the multiply polynomial, and that's a general rule. So we'll look at a couple more complicated polynomials. So we've got f of x is 8x to the 5 plus 7x squared minus 6, and g of x is 8x cubed minus x plus 1, and we're going to multiply them together. So we'll write it out. F of x times g of x is all that lot, and to do that it's good to be systematic. So what I'm going to do, I'm going to first of all do the first term, the 8x to the 5 in the first bracket, and I'm going to times each of the other terms. So 8x to the 5 times 5x cubed is 40x to the power of 8. 8x to the 5 times minus x is minus 8x to the 6. And 8x to the 5 times 1 is 8x to the 5. And now I'm going to do the same job for plus 7x squared. And I'm going to line them up as I go so that when I have to add all these up at the end, that makes it an easier job for me. So 7x squared times 5x cubed is 35x to the power of 5. 7x squared times minus x is minus 7x cubed. And 7x squared times 1 is 7x squared. Finally, I have to do minus 6 times the second bracket. So minus 6 times 5x cubed is minus 30x cubed. Minus 6 times minus x is plus 6x. And minus 6 times 1 is minus 6. And now I have to add all them up together. So for the first two, there's nothing else to add, so I can just copy them down. Then when we get to x to the power of 5, we've got 8x to the 5 plus 35x to the 5, which is 43x to the 5. Then we have minus 7x cubed plus minus 30x cubed, which is minus 37x cubed. 7x squared is added to nothing, and the same with the 6x and the minus 6. So we end up with that horrible looking thing. And what we might notice is that the degree of the product of the two polynomials is 8. That's the highest power of x. And for f of x the degree was 5, for g of x the degree was 3. And so we have that final degree of the product is the degree of f plus the degree of g.